Hello, everyone. Thanks for having me here today. It's great to be with all you at the AEC Hackathon. I always look forward to seeing this event come up, and I'm glad they came up with this 2.0 version of it, because I know the enthusiasts will always come for the 2.0 release. So my presentation today is for building your tech stack, how anybody can code in the AEC field. I created this presentation to kind of encourage people to take that leap into coding. I know a lot of people are interested in it. A lot of people, especially at the hackathon, have seen people code or have been helping code, but they may need a little bit of push themselves to get there. So I'll be talking about like my own personal experience and what you can do to develop your coding skills from like kind of a novice, limited background kind of person to someone who can at least do some basic level work. And we're going to talk about where to get started, different kinds of programming languages to start with, text editors and resources and user groups, and sharing your content and developing from there. At the end, we'll have time for questions. This is going to be to help people understand what it takes to understand a coding, not only coding language, but also make something with it. You can know Python or JavaScript inside out, but if you don't know how to use it in a developer environment to make something, it's not going to be very useful to you. So we'll talk about all the main steps to understand the concepts related to it, the starting points, and then anything like beyond that is outside the scope of this talk. You can always feel free to ask questions. I'll have my contact at the end of the session. Okay, a little bit about myself. I got my name there in phonetics, if it helps, Tadeh Hakopian. A design technologist developer with HFC Architects currently, but I have a degree in architecture, and I've been working in this field of AEC for 10 years, different fields of BIM, VDC architecture, and construction, what have you. And it's always been about trying to create the better mousetrap, trying to create a better workflow. And I think over time that kind of geared my head towards coding, something I had no idea anything about it early on, and then I slowly started getting used to the idea of trying it out and learning more about it and doing it myself. And I've been a course author for things like BIM, visual scripting with Dynamo, and coding content. So I'll put it this way: I know enough to at least explain the basics to somebody else, and maybe look up things with Google if I don't get it. So that's been my experience, and my developer path for if this kind of might relate to some of you. Is that back in 2010, right after I learned Revit, I started using formulas in Revit and using data in the building modeling to help me, just build a better design. There's no point in like just drawing lines all day or just making a dumb model in a BIM environment. You can always add parameters and context and information to it, enrich your model, and make a better model of it. This is back when I was at school, architecture school, and I was doing the very, very basics of this, and then into my internship years. And that's kind of where I was for a while. I understood enough of that to make a true BIM model. And years later, as I developed my skills, going back to BIM was visual scripting. Dynamo was finally at a nice enough point around 2017 that I could rely on it to do some work. And I was like, oh, cool, this is like an easier way. Somebody showed me a script in Dynamo, how to do some calculations for some room areas. I'm like, oh, I didn't know you could do this. This is the first time I knew about Dynamo, but I never really used it for anything. And he's like, here, use a script, we'll modify a few things. They showed me how. I'm like, wow, this thing, it did its job of doing some math calculations that you couldn't do normally in Revit. You'd have to do them manually, which is not going to happen because you have like 2,000 rooms. I was like, wow, this is what it's like to use Dynamo. This is great. And that started my journey using Dynamo that year. And as I learned more and more on it with just online resources, asking questions, tinkering with myself, I realized you can actually make your own Python code in Dynamo. I didn't know anything about the Python at the time. So I was like, okay, how can I learn this some more? So I just grabbed some resources, trained myself, and I started learning Python. And from there, I started creating some scripts, very basic scripts with Python, loops and conditional statements, and started working with the API in Revit. And then this year, I'm looking at web apps and custom products to create it. That's a longer journey in that sense because there's so many more steps involved. But that's where it took me. So you could see like it's accelerated over the years. So you'd be surprised, like you make these little steps that add up to a big jump. So it's definitely accelerated over years in my coding. This isn't including all the other stuff I did in VDC over the years. It's more focused on anything related to coding. So I was not an expert in coding by any means. I don't have a background in CS. I've learned things as I went, but this is how I can share my experience with you. And the important parts I want to leave with all of you is to get out of your comfort zone, because none of this is going to be straightforward to you right away. It's going to be something a little bit out of your experience, out of your ballpark. That's fine. Just get out of your comfort zone. You're not going to be 100% capable of all this right away, so that's fine. Just get out of that zone and start, there's always something you can learn. So don't worry that you're not perfect or you're screwing up all the time. There's always something you can learn. There's always something you can develop. I learned that as I went. Every time I tackled something, there was something new. So just get used to that learning curve. It's just going to be part of the process, and just try something. Don't feel like you have to have the perfect project laid out. Many of us at AEC always have this idea where we're conceptually figure out the project and then work in the details. A lot of coding is like that, but of course you need the experience to inform that concept. So until you get to that level where you're very comfortable with the conceptual level and the backup, the experience that takes to understand how to make that conceptual level real, you just have to try a lot of different things, a lot of iterations, and you'll get there. So don't be hesitant. And if you're thinking, should I do this? Is this relevant? Here's some questions. Do you like to think through problem solving of any kind? Are you interested in visual script programs like Dynamo and Grasshopper and other scripts like that you can visualize a solution? Do you like to read through online posts to solve problems? Do long-term projects with updates sound like something that work for you? If you think any of these work for you, you could be a coder too. You pretty much have all the natural instincts and leanings to want to do code. It's like anything else, it's a learned skill. And some people, when they think of coding, think of some kind of hacked algorithm that's really abstract and hard to read, and it seems like very daunting. And how would you ever learn all of this? The reality is most coding is very easy and straightforward, and once you get the hang of reading the code, you can actually read most code pretty quick. You may not be an expert at it, you may not understand exactly how it works, but you can at least kind of dive into it and understand a little better. It's all about adding lines in text. That's what code is. It's text lines for a computer CPU to complete a process. You're just telling the computer some steps through these lines of text, and then you execute that text script to perform a process. And a lot of the time is actually not spent trying to be, some kind of mathematical hacker. You're actually spending a lot of time just trying to figure out why something isn't working. It can be very mundane and routine, like you didn't, set up the correct access information to a login profile or something. It has nothing to do with, algorithms and machine learning. It's just something very mundane and routine. So a lot of it is actually making sure everything works properly. It's not as crazy as you think to get started. So if you're thinking, okay, great, I would like to get started. How do I get started? One thing I would encourage you to do is while it's good to just kind of, like I said, get started, don't be hesitant, just get out of your comfort zone. Also figure out what interests you. What problems do you want to solve? What kind of solutions do you like to have created? That can give you a good starting point, because from there you can think, okay, if there's something I'm leaning towards, what would that be? Maybe you want to have a better way of, data transfers between different kinds of models. That's been a big topic in AEC. How do you get the data out of one model to another? Maybe you like to make some more free-forming designs. That could be one. It could be all sorts of things. How do you communicate an idea? Think about what you're trying to solve, and it could be a broad, abstract concept. Again, the hackathon had plenty of this idea thinking going on. That's how you started. And from there, you can figure out what it would take to get there. And there's a couple of paths there. There's web development, there's anything to do with data engineering, and then there's general purpose scripting and development. Web development, for those of you who don't know, in this world, it's basically HTML, CSS, and JavaScript. We can talk about PHP and C#. There's many other tools. I would say in this day and age, if you're going to get started like fresh, it's going to be HTML, CSS, and JavaScript to keep it simple. And it could be, depending on what you're doing, the front end, which is all the visual stuff that you click on when you get to the website, or the back end, which is the stuff that talks to a server to get updates. Don't think too hard about that. Just realize the front end is going to be the HTML, CSS, and JavaScript. Everything is becoming an online web tool. So this is actually a pretty good skill to learn if you want to make tools, interfaces, products, things that it's like, okay, I want to do something that's easy to share a model online for 3D. This is the place to be, is web development. You have to learn JavaScript. and the related languages to it. And there's a whole ecosystem out there just for JavaScript. And here's an example. You would start with just learn the basics of HTML, CSS, JavaScript. And from there, you can get into different varieties of how to use these tools. So I just start from the very beginning. If you're going to start from zero, it's going to be these three, HTML, CSS, and JavaScript. And you can do a ton of that, work with just these. And then from there, you will understand enough once you figure these out to evolve. And we'll talk about what it will take to get there. And by the way, web development is a constantly changing environment. A lot of growth in this sector because everything's moving online, but it's constantly changing. So something gets updated and modified quick, and within a year, you have to get familiar with a different kind of ecosystem for web tools. So just FYI there if you're interested in that. If you want to do anything with data engineering, that's a different world. That's including machine learning and AI, autonomous systems, neural networks, data minings, learning algorithms. There's a lot of stuff in the data engineering world. It can be related to web development, but it ends up being its own little field. Python is very, very heavy in this world. So that's a different coding language than JavaScript. JavaScript runs in the browser. Python, it runs its own implementation. And any of these tools right here, any of these methods can be done on a large or small scale. There's not one path here. These are not all interlinked. They have a similar set of core skills, but there's a lot of variety. And this is where you get into more algorithms and creating a little more complex systems, but there's actually a lot of great resources out there to help you along. So if you're thinking, what would I need to do with data engineering of any kind, AI, ML, Python would be a good starting point for that kind of system. And then if you're not really clear on either of those, realize that there's plenty of room for just system integrations where you try to connect one service to another service to another service. Like, and this is what you do with the applications programming interface APIs for different software, where you can have different clients and apps talk to each other. Android apps talk to a web platform that can then also talk to an iOS app, so on. You just connect the service at the end. A lot of developers do this kind of work. And this is also where you do some basic scripting. So you might actually start yourself out here where it's easy pickings, and there's a lot of different solutions to problems you would have ready to go. So you don't have to be an expert in web development, machine learning, or anything like that to do any of this. You just have to know enough about the API. That has like a type of software. Let's say Revit or is it API right now has an API. They all have API. YouTube has an API. Everything has an API. Learn enough about that. Use some kind of coding language that interfaces with it, and you can start scripting solutions. So this isn't probably where a lot of people would actually start. That's where I started. And the easiest steps to get started, if you're like, okay, great, but like maybe I'm not ready there, you actually have a couple choices to really understand the fundamentals. Visual scripting, of course, there's a logic to visual scripting that, as you can see here, the left side is the inputs, then you go through a process in the middle, and then you go through an output on the right there. And we've all seen this in some kind of visual scripting language. Helps you understand the basics of coding. That way you can move to textual coding. HTML, CSS, very easy to pick up. There's plenty of rules, but you don't have to do like anything fancy to get to this point. It's very straightforward as a learning tool, and you can learn a lot about web interfaces and web development with just these two codes. You'd be surprised how much information's in here, and a kid can learn this stuff. It's not hard. There's nothing really challenging about it. And there's this fun thing that is for kids called Scratch, which helps you understand the logic of how to create a function and a loop. And I recommend anybody who's like just intimidated altogether, they don't know where to start, go to Scratch. It's a free tool online that you can help you understand how to create coding processes and coding language logic. So let's say you get over that hurdle, you feel a little more comfortable with the full-on language. Which one do you want to learn? Here's my breakdown. For web tools, JavaScript. There's many others, like I said, PHP, even Python can help you. But basically, if you're going to work with any kind of web application whatsoever, like you really want to do this, you need to know you need some degree of JavaScript. You can be a very advanced user or a very elementary user. You need to learn some kind of JavaScript if you're going to be more heavy on web tools. If you're thinking my world's going to be basically anything touching Windows and .NET, which is pretty much applications for Windows, C#. That's a perfectly good language, a little more verbose than JavaScript or Python, but not bad. It's still pretty popular because everybody uses Windows. And if you want to do anything with data, machine learning, AI, or just general scripting, Python's a really good start. Probably the easiest language to learn out of the three I list here. Probably the easiest language to learn for the most part in a popular development environment. So that's a good start. And if you have no idea still, I would just say start with Python because you can learn a lot of basics from Python. But it was easy for me to dive into. There are some things I had to kind of get over a hurdle with Python. Python makes it really easy to just start learning how to code. There's not a lot of syntax. You can actually read the code very clearly. Once you get used to it, you can say, okay, I get this. I know what this programmer is trying to say with this code. Whereas C#, a little more verbose, and you have to understand how that language is written in the syntax to read it. Python's closer to just language. So if you give it a shot, you'll see what I mean. So I would start, if you have no idea, start with Python. And there's other ways to learn. This one here is a visual scripting tool that's actually Python. It's Python visual scripting. Now, if you're just a computer science student, you probably wouldn't use this because you just go straight to text coding. But if you're comfortable with the visual environment, there's tools out there. I have the GitHub repo for it's called PyFlow, where you can use it to combine your interest in visual scripting with interest in learning Python, for example. This is a good one. It makes it pretty clear to understand the inputs and outputs and get you going so you can feel comfortable with the next level of doing textual coding. And so let's say you're like, cool, I want to use one of these languages and I want to get going. Get an editor. I think these are the kind of things they don't really tell you because it's almost like too obvious to tell you. But I started with when I installed Python a few years ago, when I first started using it, I used the built-in text editor for Python called Python Idle, IDLE. Very, very, very basic, doesn't have a lot of features. So that's how I realized I had to level up my game. And I realized if you don't have a good text, Notepad on your Windows computer is a text editor. It sucks, it's not a good text editor, but it's you can at least open the code and look at it. But with a good text editor, it can help you read the code easier. It can help you tell you if something is a typo, a mistake. It can help you debug the code. So a good text editor is going to go a long ways to help you be a good coder. So there's many kinds of text editors. There's probably hundreds out there. Some of them are very popular. Here's just a quick breakdown of different kinds of text editors. I hear a lot of good things about Atoms, Plain Text, and Notepad++, Vim for the hardcore at heart. And there's a lot of them. So don't feel like there's one perfect text editor. Some are more comprehensive than others. Just find one that you like, ask around. And if you have no idea, just use Visual Studio Code. It's pretty good all around. Microsoft products, so again, Windows, it's pretty easy, but it's cross-platform, so work with anything, Mac, whatever, Linux, it doesn't matter. Pretty good. I'd say this is probably the best one you can start with, and then you can figure out if it's the right place to be or not after that. So this is my recommendation if you have no idea. And now that you have all your setup ready to go, learning styles. How do you learn? This might be taken for granted because some people just kind of intuitively understand this, but are we visual, auditory, text, touchy-feely learners? You have to think about that a little bit because it helps. If you're in AEC, probably more on the visual. I'd say most people in AEC like to, designers of any kind, engineers, like to look at things and understand them. And so think about if you need lots of charts and references, or you can just read through everything. Think about what motivates you to learn and what you're comfortable with as a resource. I'd say for the other thing you want to keep in mind is if you're a linear learner or a non-linear learner, meaning do you like to go through steps 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until you complete a series, or will you get, and you're comfortable with that, it's fine, you like it, that works for you? Or are you non-linear, meaning you're fine with taking the first few steps, you want to jump around a little bit? That's me. I'm more on the visual side, a little bit on the text side, and I'm non-linear in that sense. I like to just kind of learn a little bit, jump around, learn a little bit more, and it might take longer in that sense, but it helps me stay focused over the long term. This is a long-term project I'm talking about, is learning and continuing to learn. So think about what kind of styles of learning are good for you and how you need to absorb knowledge so that you find the right materials out there that are suitable for you. This is all, again, something else that gets overlooked. And for learning resources, once you have everything else set up and you know what you're looking for, there's a ton of learning resources out there, and it's not always easy to sort them out. As you can see, you're kind of cursed with choices in this world of learning to code and you understand the technical side of things. These are all great resources. They all have their pros and cons. Some of them are pretty minimal. Others are, vetted. Others are not vetted. Udemy, just anybody can submit a course to Udemy, and the crowdsourcing tells you, yay or nay, 4 stars, 5 stars, 2 stars if it's a good course. Others like edX and Coursera would be more vetted, or they're full-on courses. And there's everything in between. So you do have to kind of learn the landscape a little bit, but you'll see through the different courses out there what's good, what's not good. If you want a really easy starting point for just language coding, that's kind of a good start, and you can find out what your style is, what you want to learn more of. Google has some great series. I recommend these if you want to get started just blank. If you don't know anything, Python and JavaScript are on these links right here, and I'll send the deck out to everybody. But you can just even type in Google to find this information out of like how to get started learning Python and JavaScript. That's a good starting point because you do need to understand the fundamentals of each, and then you can think, okay, this is where I need to go in this case. This is my next step will be after I learn this basics. So don't feel like you have to solve this all right away. There's always an easy step. And pro tip, you can actually get through an LA public library card, full access to LinkedIn Learning, the whole thing for free monthly. There's no, and many libraries across the United States, maybe across the world, can have a similar program where you can get free learning resources because they have these kind of programs. So LinkedIn Learning can definitely be connected to your LA Public Library card account, and you get the whole thing. They have a ton of curated, very detailed learning courses. They take longer to learn just because there's so much curation. They're not too heavy with content. They're just thorough. So that's another resource if you want to do something a little more vetted. For me, one of the cool things I found over the years is this thing called Hyperscale by JetBrains. JetBrains makes text editors and developer environments like Sublime Text and a few other text editors out there. And they have this whole academy. It's paid, but it's perfect for me. It's not linear. There's a lot of good text and visual cues in there, and I can learn through its branch tree how to learn a coding language or a system. It's pretty comprehensive, has a community on Reddit, reinforces your learning with repetition. So I found something that works for me. So find something that works for you. I didn't find this the first time. It took me a couple years before I ran into this. So it's pretty cool. So don't feel like you have to find everything right away. And once you get to a point where you even have a basic lesson plan, where like you're typing out some basic conditional statements or hello world in Python or JavaScript, whatever, put it on GitHub. Learn GitHub sooner the better. Just go on. It's free accounts. It's a lot of free stuff on GitHub actually, and you can learn the basics of version control, uploading files, making issues and comments, even while you're just learning to code. The basics. GitHub's a pretty good resource. You probably have to learn it anyway. GitHub works with Git is a version control. Basically, it's saying if I upload something to a Git environment like GitHub, I can track the changes over time, either for myself or a team of people working on the same repository of code, collection of code. And if we make mistakes or we want to go in different directions, we can either roll back or branch off with GitHub. So I highly recommend that you learn this along the way. It's not hard. It's kind of like Dropbox for code, if that makes sense. So try to do this as you learn to code. It's not software programming in and of itself. It's just a tool to help you program, just like VS Code. And if you need help on any of this, the internet's there to help you. There's Quora. That's a great question and answer site. Stack Overflow, really great place to ask technical questions about like my code doesn't work on line 5. Can you help me understand why it's not working on line 5? There's usually somebody who has an answer. Reddit's a good community. You can ask for just about all that stuff. How do I do this? You guys have a good resource on learning this thing. Reddit's pretty good. Lots of subreddits. Too many to list here, but you could definitely find all sorts of learning resources on web development and machine learning and everything on Reddit. I highly recommend checking that out. And if you still don't know, just ask Google. You can literally just type into Google, how do you solve a problem? And the better you know the jargon of the code, whether you're looking for a data type, like a number versus a float versus string, whatever, the easier it is to ask Google how to help you solve the problem. But do get used to this. The vast majority of programmers out there, no matter how experienced they are, do this exact same thing every day. So just get used to finding ways to answer your question and being clever about it to help you along. And nothing wrong with going to a repo like GitHub and just copy paste code. Usually, if it's online and you can copy paste the code like you're seeing here, that's a sign that they didn't care if you copy pasted the code. Give credit where credit's due. You can put it in the notes of your code that I got it from this repo, both to credit the developer, but also just let people know where you got it in case it's not yours, so they know where to go if they need to find the updated version or whatever. Perfectly fine. Just don't plagiarize, right? And just to give you a little more encouragement, lots of software projects have been launched by people from AEC, just like at this hackathon. AEC people doing hackathon projects. All of these projects, PyRevit, HyperR, TestFit, Layer, they all had people from AEC world come in and either be product managers, which help develop the software, or they just straight up develop the software from get-go. Layer was developed by Zach Soflin by himself, and he then got a team together to a startup. he worked at an architecture firm, created the basis of it. It's now a digital twin tool, and he had no experience coding. And I think this was 5 years ago he started this, and now he has his own company. PyRevit is an open source project by Asan Iranijad, and a lot of people have already heard about this and love it. Great tool. He knew coding, but he also wanted to make an open source project. So again, these are architects and designers who want to enter the world of coding and programming. So plenty of good examples out there. It takes a while to get to a nice refined point, but it is totally possible. Just you have to keep at it. So this is a marathon, not a sprint we're talking about. And I would say other software projects to pay attention to, which might be the future, is anything going on with Blender. Blender itself is completely open source. You can go download it for free right now. And if you want, since it's open source, build your own version of Blender. And there's one cool add-on called Blender BIM by Dion Molt, and he uses it to uses this with Blender to exchange IFC files from Blender into different BIM formats like Revit and Tekla. A very cool tool. You can basically model everything in Blender 3D. Kind of think of like a Rhino to Revit workflow, but instead it's Blender to Revit or something else. This might be a perfect place to explore future development options for anybody who wants to know what's the next step after they learn a lot of coding and can create their own products. Plenty of room to grow. And there are plenty of groups to help you. I'd say hackathons like this one, AEC Hackathon, are great learning experiences. You learn a lot in a short amount of time with hackathons, boot camps, workshops. Probably some of the best places to really get your feet wet with actual full-on let's make a project coding, because it goes so fast and you see every step along the way from concept to deployment to shipping. And there's the ones I see a lot is of course AEC Hackathon, the Core Studio by Thornton Tom Study has hackathons. They just finished theirs last weekend. There's a SFCDI now. They used to be SFC Doug, but basically San Francisco Computational Design Institute. They have a lot of great meetups. They had one yesterday. And meetups locally like LA Rug and other user groups in the area. So connect with these people, talk to them. We're all virtual these days, so it's actually easier to talk to them than ever before. I highly recommend getting involved in these groups, just asking questions. I had no idea what I was doing when I was entering some of these groups. And I would say go beyond AEC. Remember I said go out of your comfort zone. Go to tech meetups, pure tech meetups. I went to Apache Kafka meetups. I have no idea what Apache Kafka was. I just went. It was in my area. And there was something going on. I'm like, screw it, I'm gonna go see what these people do. And I went to Python meetups back when I was barely able to understand Python code, JavaScript meetups. I went to see any kind of meetup, product designers for software. I really didn't know anything about what they did day to day, but it's exposure. I get to see what they do. I get to see their culture. I get to see how they work. I get to see the things they pay attention to. So these kind of things are ideal to attend anything that you want to explore more to. There's usually a meetup. And these days, everything's virtual, so it's actually very, very easy to go. Ideally it'll be in person, but we'll get there down the road once everything goes back to normal. So just feel comfortable going to meetups. Get on those Discord channels, get on those Slack channels, and just talk to people. That's probably the best way to learn more and ask questions. I met a lot of user groups that have one group I met on Reddit to help you learn web development. One of the people there is like, hey, I'm interested in, I'm an experienced web developer. Do you guys want to do a web developer Slack channel where we help each other learn web development? And I joined it. And so I've been learning a lot through just this group that casually we just got together through Reddit onto Slack. So you'd be surprised who you run into who can help you along the way at any of these virtual or in-person meetups. So I highly recommend networking and finding people to connect with through the long term. And people to follow, I list this here. I'm not gonna go over everybody here, but these are lots of, again, you look at this deck here. It'll be recorded and I can also send it out. There's lots of great people who are on Twitter. I highly recommend going to Twitter and following people in this world, like I mentioned Asan and so many other people. It's because you'll see what they're working on. You can directly message them and follow them. So I highly recommend Twitter as a resource and LinkedIn. And now that we get all that out of the way, I want to mention that how long would it take to actually study and get something done? It depends how intense you are and what you're trying to achieve. If you're doing the traditional computer science degree in college, that's a 4-year program, right? So you learn comprehensively 100, whatever it is, 150, 180 units, whatever they do, of course credits, right, to get a CS degree. But it's much more theory, kind of like what we do at any school. There's a lot more theory than practicality. Doesn't mean they'll teach you JavaScript and Python, how to make a website in college, but it does mean you have the understanding of the basics or the strong understanding of fundamentals after 4 years, including problem solving. But if that's not your thing, you're like, I don't have 4 years to spare, whatever, that's fine. But it is the most intensive way to learn. in that sense because you're immersed in it year after year. But there's plenty of alternatives that are just as good. Self-study, I put down 6 to 12 months. That was relevant. That made sense to me. That's how long it took me to really even understand the basics of coding. I started with Python. I've been learning more JavaScript recently. It does take time, just because you may not have full time, right? You may only have like a little bit of time in the day. That's fine. It's like if you have like 40 hours a week of this, you learn a lot. But if you only have an hour or so a day, it might take a year before you feel really comfortable doing what you're doing. And if you did a full-on coding boot camp, maybe you might have heard about, where you're in person or virtual learning a subject, that's like closer, depends on the boot camp, but if they say this is full-time, there's part-time and full-time. It's full-time, it's pretty much 40 hours a week. One boot camp in LA I heard about would be, they said 9 a.m. to, I don't know, 8 p.m. every day, Monday through Sunday for 12 weeks. So, and they're trying to, that's drinking from a garden hose right there, just drinking through a hose, just tons of information coming at you. So in 3 months, you might be very, very well versed in whatever they're training you in. So just think about like what method you're trying out here, how much time. If you're working, and just work on real projects. Once you get over the basics, work on real projects, something that's applicable to your day-to-day life, your work, whatever, a personal project, just a real project. And keep a journal of the amount of time. It's easy to forget. It's been 4 days since you last did something with coding. You just always have a tracking mechanism. I have a spreadsheet myself to see if I've been doing something every day. My rule is more than 0 effort into work every day to see progress. So even if that means 5 minutes of work reviewing your notes from the day before, perfectly good, because you're developing a habit of learning to code in AEC, or just learning code, learning anything new, period. Learn to code so that you don't neglect it. You have to do this day in, day out, a little bit of work every single day. And that could go on for months and months and years. That's perfectly normal. Don't feel like you're stuck or anything. You just have to do it consistently until it becomes so ingrained in you that you just go do it. And to prove that point, here's my chart of days where I learned. I've been tracking how much Dynamo I've been developing and working on, and how much JavaScript as like a recent effort going on. You see at the end here in September, and I've been going on since September, since a month ago. I've been continuing this progress. And the only days I had off were days where it's, I was on a trip or something, and I was just taking a day off, basically. Otherwise, I've had at least a few minutes and upwards of hours a day spent on this. And you have to keep track of what you're doing. So I highly recommend doing at least, again, 5 minutes, 10 minutes, anything every day. Ideally, it's more, an hour, 2 hours, but whatever you can do it consistently. Track your progress so you don't fall off, and just figure out what you're trying to learn. This is a big, helpful tool. And here's some projects to try out. It's Python Grasshopper. That's from McNeil, developer. It's pretty cool. Python Grasshopper, any Python and Rhino API is pretty easy. It's a good, easy start for people who are familiar with the McNeil tools like Rhino. I'd highly recommend it if you're comfortable with that. It's pretty good documentation they have to help you out there. They're not going to teach you Python right away. They might have some basic instructables, but they'll definitely show you how to use it in their environments. Python Dynamo has there's a basics in Python primer about Python and Dynamo to get you kind of familiarized there. That's where I started when I started learning Python and Dynamo. Data science and AEC, this is an edX course. This is really great if you're just interested in data science. It's for data science for architecture and engineering construction projects. So highly recommend that if you want to learn more data. There's web development of Forge. I am this week doing a boot camp on this exact subject. And I highly believe that web services and web tools are the future of everybody's work, doesn't matter which field you're in. So I want to learn more about Autodesk's Forge web services platform, where they host all their web products. That's a good tutorial, and they have a lot of great support. At the very bottom is automate the boring stuff, and maybe I should have flipped this, because automate the boring stuff is Python, and it totally shows you how to do things like automate email messages and doing things with Excel and PDF with Python. Very good stuff there to get you familiar with how to code in a real world environment. And just remind you all, you're never really going to stop learning code and understanding more code. It never ends. Programming environments change constantly. If you install something for a big popular package for JavaScript, like the package is NPM, Node Package Manager for JavaScript, that thing changes constantly. There's a whole ecosystem of JavaScript that changes constantly. Python is currently on 3.8 maybe, and every month or two they upgrade it from the last version. You have to get used to things changing. You have to get used to things what they call deprecating, meaning it's no longer useful. You have to adjust your code or update your packages and learn new things. New things come out. JavaScript and Python are relatively old, but they're evolving constantly and new things are popping up that in 5 years we might be talking about that. It never ends, so don't feel like you're gonna hit this point where you learn everything. That's not gonna happen. Just get comfortable with always being a learner, and everything else will work itself out. And real quick on my learning path, I talked about this a little bit earlier, but it was basically true, like, before everything at step 0 is BIM and maybe some Excel formulas, I guess. That's the best I can tell you. Then it was visual scripting and Dynamo. Dynamo was my gateway. If it wasn't for Dynamo, I probably wouldn't even bother coding, because Dynamo introduces you to ideas like data types, like strings and integers, in order to get anything done with Dynamo. And because Dynamo had a Python node, I could then start doing text editing in Dynamo, which introduced me to Python, which got me comfortable with working on my own kind of solutions with Python and Dynamo. And from there, I can just say, I could just start doing Python outside of Dynamo and Revit and just do general file automation work. And then my future at the end there 5 is just creating tools with graphic user interfaces. So that's kind of been my learning path myself after what I've showed you is this evolution. Visual scripting tends to be a no-code, low-code environment to get started, and you might, like me, get hooked on and want to learn more. I'll quickly go through this, but the benefit of like Python and Dynamo was you could take all this chunk right here in blue and just distill it into text code. Once I realized that you could just, this is what everything in blue, all the nodes here, just you can make it into this text code, and it's pretty easy to read. I was like, okay, I'm gonna do more Python. This is what I want to see. It's hard for me to follow this much nodes at visual scripting in general. It's just so much content here, but when you put into a line of text that's like half a page at most, it's easy to follow. So I highly recommend anybody who's doing a lot of visual scripting, dive into that Python or C# world and start working with that. You might thank yourself later. I highly recommend this. If you're already pretty comfortable doing this kind of work, long scripts, you could probably figure this out pretty easy. And this is my example of it, where I took something that would be a bunch of nodes and looping around. Loops are pretty easy to do and get you a lot of cool results, and they're easy to edit. If you want to see more, I have a whole Autodesk class on, they're called Python Nodes and Dynamo at Autodesk University if you want to check that out. It's all recorded online. It's all free. It ain't much, but it's honest work for me. It's a good starting point. It's kind of resources I make that I hope other people can get something out of. And I'm going to have to skip the HMC stuff, but basically at HMC, just to save some time, but HMC is where I work. We have a digital practice where we're trying to create, and everybody in the digital practice has an AEC background, one way or the other. None of us are trained to be coders. We do have a development team at HMC that helps us, develop something a little more sophisticated. But as far as the digital practice ourselves, we all came from a non-CS, non-coding background, and we've done a deep dive into how we can make the better tools and resources available for our company, so that designers and architects and people in our world can have an easier time with designing using modern digital practices like databases. Databases are the data and databases, and using that data is the new big thing in AEC these days. And we're all coming together to create a database of all the data sources in HMC. So that's something we've been learning on our own as a group, how to do that better. So this is an example of how you can take each person's knowledge of one thing or another and put it together to a big project. And our goal is to create a database that can create training profiles for people. And so we know who's capable of what, if they're good at Grasshopper, Dynamo, CAD, Revit, to help create project teams suitable for the skill sets necessary to make a successful project. That's something we're working on internally as a team of people. And just to give you a little inspiration that once you get to a point where you feel comfortable enough coding, you don't have to be expert. By no means do I feel like I'm an expert at anything. Just good enough to do something. Then you can start making tools that can affect your day-to-day work. I highly recommend anything you do, try to tie into your day-to-day work. So not only can you do it more frequently and to the advantage of your project and your company, but also you can show it off to people who are like, managers and, the executives of your company, saying, look, I can make something for you in-house that can solve some problems. That's a good way to get people's attention and encourage you to continue developing your ability. And so I want to reiterate this to important parts: get out of your comfort zone. I had no idea what I was doing a couple of years ago when I started this. I just I should probably learn this. So I started learning it. I knew there's a ton of things to learn. I didn't get overwhelmed trying to learn 20 things at once. I focused on how do I do this Dynamo stuff, how do I do this Python stuff, and go from there. You do have to understand those fundamentals. Otherwise, the more advanced stuff doesn't make a whole lot of sense. And just try something. I tried it out, like I said, Python, Dynamo, and from there I just did something a little more sophisticated. Now I'm doing web services with Forge. It's not like you have to do it all at once or you have to know exactly what you're doing. Just learn. It's all new to you, so just try something. And that's what I got to say. I said, get going. The sooner you can, if you're interested in this whatsoever, whether you feel like you're gonna, this is for you or not, you won't know until you try. And you do have to put some effort into it. So get going, figure out what you want to do. Just try a few of those courses I have mentioned here. Ask around. You can always add my contacts right here if you want to get in touch with me, ask me any questions, pick my brain about a few things. Yeah, a lot of people help me along the way. I should mention that. I constantly ask people questions. I constantly ask people how to get help on this or that solution. So I'm there. If I can do anything, I'll help you out. Or if I can't figure it out myself, I'll point you to where you can go. And there's lots of people out there helping each other out in this community. So the sooner you get started, the better. And the sooner you feel just you have these projects going and you learn these lessons, the better. So I think anybody who's interested can do this. It's never been easier to learn how to code. 10 years ago, it was a little bit challenging. 20 years ago, you might as well have gone to a computer science degree. But these days, it's pretty accessible. So that's all, folks.